Oh, hello, and welcome to part 2 of trig functions and cyclical graphs. Today we're going to be graphing sinusoidal functions. So we took a little bit of a look yesterday, and by yesterday I mean yestervideo, at the effects of A and B as transformations on sinusoidal functions, y equals sine x and y equals cosine of x. We looked at how the value of A affected the amplitude, which thus changed the range and the max and min, and how B changed the period, how frequently this graph went all wiggle, wiggle, wiggle. We'll also be applying translations, so moving these graphs left, right, up, down, and then graphing based on transformations, each sinusoidal function. When we take a look at what's involved in a sinusoidal function, we note that there are some distinct points, like for sine of x, there's that start which usually happens at 0, 0, and then at pi over 2 it reaches 1, at pi it reaches 0 again, at 3 pi over 2 it reaches negative 1, and then finally at 2 pi it reaches 0. And so we have some key features where we have this max, we have this min, but there's also this middling line halfway between them. And that's worth noting. So when we take into account the vertical scale and what we're going to have to do for that, we're going to look at that max, the min, and average value. We don't need to indicate a ton, but as long as we can indicate those three, then we're good. Of course, applying the appropriate amount of tick marks for each one. For the horizontal scale, it can be a little kooky, but there are some things we need to consider, and namely the period and the phase shift. So this phase shift is over here, how far we're shifting left and right. The phase shift takes this initial point for sine of x, or this initial point for cosine of x, and shifts it left or right. So it tells us a starting point, and then how far over is the next point. Well, for that, we can note that what we've got up here is 4 distinct intervals. We've got this one, this one, this one, and this one. We've got those 4 pieces of every period, or for cosine of x, if you want to say that starts at there, then you have 1, 2, 3, and 4, and then cosine function starting again, right, where this is one period of the cosine function, and this is one period of the sine function. So noting that we can say that there are 4 components to one period, we can take the period and divide it by 4 so that we can find out how often other points occur. So for these 2 functions here, we're not going to graph these ones quite yet. We will do that on the next page, so it's pretty soon. We're going to state the max min, we're going to state the range, we're going to get the amplitude, the period of each function, and let's just talk about how to indicate the scale of the axes to graph each one. Take a moment, see if you can note from your knowledge of transformations any of these things. We know how to get the range and max and min and amplitude based on the value of A. Of course, now we have another vertical effect, and that's this value of D at the end. And we've got a means to find the period, which is still based on B, and that's not affected by the phase shift, so the period stays the same as it would be based on B. Anyhow, let us jump in here. I'm going to say that the maximum is equal to 1, and I'm going to say that the minimum is equal to negative 5. Why am I saying that? Well, normally we're going from negative 1 to 1, but we multiplied by 3, and then we subtracted 2. So keep in mind those ideas with transformations that apply here. So I've got a max of 1, a min of negative 5, and I've got a sick eraser. Look at it go. So the range here is from -5 to 1. Woo! What's the amplitude? Well, the amplitude is equal to the value of A. That's just straight up 3. When it comes to graphing, we need to make sure that we indicate -5, 1, and whatever is halfway between them to, again, get that average part of it. Halfway between -5 and 1 would be -2. The period of this, P is 2 pi over B, as you may recall from our previous lesson, which in this case is 2 pi over 2, which is pi. So we've got a starting point, starting in quotation marks, because technically it could start anywhere, but it starts, this one has shifted pi over 6 to the left, and then we have other key points every period divided by 4. Again, noting that there are 4 segments that we can acknowledge within every period. And that's that. That's what we have to acknowledge when it comes to choosing our scale there. Quick, try the other one. Hopefully you paused and you resume now. Because here I go. Maximum here, 1 times 2 plus 1 is 3. The minimum is -1 times 2 plus 1. So the range is that. The amplitude is 2. So for graphing, we need to make sure that we're having tick marks for y values, the very lowest at -1, at the very highest at 3, and then halfway between that again, so that we get these points here. So halfway between -1 and 3 is +1. And that's that. Period is 2 pi over B, which is 2 pi over 1/2, which is 4 pi. What do we gain from that? We have what we can call a starting point. This thing is shifted 90 degrees to the right. And then we have other key points. Every quarter of this period, which is just every pi. Oh, you know what that means? We'll have to turn this into degrees. And every pi would be 180 degrees. 4 pi is what? 2 pi is 360, 4 pi is 720 degrees. That would have been a mistake. We should keep our units consistent. So there's that. Phew! Now, we're going to graph these, and it's going to be pretty wicked awesome when we do this. The things we'll keep in mind. We can keep in mind transformations, so we can graph this through transformations. But when we do that, note that it takes time. And to do every transformation of a sinusoidal function it's going to occupy some of your time. So if you can do a faster way, if you can note max min where this kind of so-called starting point is and go from there, it will be much faster. So this first one I'll do through transformations because we can. We have to show at least one full period. Okie day. I'm sure that will give me enough. We're going to have to pick some things here based on the fact there's no plus minus out here. This is going to tell me we're just going from -2 to 2. So then I'm going to make sure my scale on the y-axis at least gives me that. Here's 1. That can be 2. Sure, there's a third one up there. There's 1. There's 2. That's all I needed. For the x-axis, we've shifted left 30 degrees. There is no change to the period. There's no b value other than 1. So I'm just going to make sure that I have tick marks every 30 degrees. So that's a 1, that's a 2, that's 30 degrees. So I've carefully chosen that. And I'm also carefully making sure that my tick marks are decently evenly spaced apart. I don't know how many you'll need. I'm just throwing on a bunch. It might be that there's extra, but it's better to have extra and just be able to erase what you don't need than not have enough and have to extend it, because that sucks. Little arrowheads there. Let's throw my y over there. Let's throw my x over there. All right. If I do this through transformations, then it's based on y equals sine x. And y equals sine x has a key point at 0, 0. At 90 degrees, it's equal to 1. If you want to picture a unit circle, there's 90 degrees. Y is equal to 1, so sine of x is equal to 1. That's 90, 120, 120. At 180 degrees, it's back to 0. And 3 tick marks later, it's gone to -1. And then finally, at 360 degrees, it's back at 0. So we can sort of connect the dots, but this will be a dotted line because this is definitely not our finished product. Note the gentle curvature that happens with this graph. So it's not going like this, this, this. There's definitely not that. And nor are we going to go like this. Oopsie daisy. Definitely not that either. But it's not like it's going suddenly up and suddenly down. That there is a graduality to it. That's our base graph. We apply transformations. We can multiply by 2. Do-do-do. 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 And then finally, shifting left 30 degrees. Every tick mark is 30 degrees, so we're just shoving 1 tick mark to the left. There's 1 left. There's 1 left. There's 1 left. There's 1 left. And there is 1 to the left. Now we can connect the dots, and we can do that with an actual solid curve. And again, graph this as if you almost even care about it. So I'm using these little sketchy sketch lines because I want this to actually look good. Doesn't have to look perfect, but it certainly has to look like you tried. Would this be 1? When x is 0, 0 plus 30 degrees is 30 degrees. Sine of 30 degrees is 1/2 times 2 is 1. Wow, it goes right through that point right there. That's kind of exciting. Now let's fix this up. This one's considered done. This would have been worth 2 marks. 1 for this transformation, 1 for this transformation, which is not a whole heck of a lot of marks. If it's 2 marks, using our 2 minutes per mark kind of basis, that means we want 4 minutes on this total. We spent, at this point, a while on it. And part of that is because we drew the initial state, we drew this first transformation, and then the final product, which can be a lot. So again, if you can do this without doing all the transformations, that's most preferable. And I'll be doing the rest without doing all the transformation steps in between. Of course, I'll describe my process. Try the others. If you need to use transformations, go for it. If you want to watch this next example, that's cool too. But there are just 3 more examples to look at, and that'll be the end of this section. All right, this graph here, y is equal to cosine of 1/3 x plus 2. So I'll need some axes. As I prepare to graph this, I note that I'm going to be shifting up 2. So, like if my other axis was over here, that wouldn't make sense. Oh, got rid of a lot there. That's still there. Perfect. And maybe even like the middle doesn't necessarily make the most sense. So what I might do is just shift this other axis down a bit, just to give me more room up top. Because I'm shifting upward, I'm going to need to indicate higher values. My range here is going to be from 1 to 3, because I've shifted up 2. And I can take that into account when I indicate my scale. That I'll have to have a 1 and a 2 and a 3. And just because there's room on my axis, I'm going to indicate that 4th one. So that's a 1. We've done something here. We've modified the period. The period is going to be now 6 pi, because I've multiplied things by 3. How often will I have key points? If we divide that by 4, we've got 6 pi over 4, which is 3 pi over 2. So for scale, I could indicate things just every 3 pi over 2, or I could just go with pi over 2's. Maybe. It's not necessarily the best, but we'll try it. We'll see what happens. So this can be pi over 2, 2 pi over 2, 3 pi over 2, and so on. Sometimes when I do this, I also indicate other values on here because I know that 3 pi over 2 is necessary. I might put the 3 pi over 2 because I know that there's going to be another key point, 3 pi over 2 after that. I might just go for that as well right over here. So 3 tick marks after that is now 6 pi over 2, which is 3 pi. Another 3 tick marks after that is over here. Oops. And I might just keep going with that as I go along. Man, I could have spaced this out way better. Oh, too late for that. It's not. I could erase it. I could try again. But here you can see that effect of maybe having too much room, not needing it. 1, 2, 3 tick marks is 12 pi over 2. And that should be all I need. Now the graph of cosine of x, right, the regular one, starts up here and then goes down and up and down and up, since cosine of 0 is 1. So this graph is going to mirror that as well. Our starting point is way up top. It happens still on the axis. We haven't shifted left or right at all. We've just shifted up 2. So we've got the point way up here where y is equal to 3. And from there we're going to get our other values. Another pro tip I'll throw in here is just throwing in a guide for that middle line. We know our top is 3, our bottom is 1. Halfway between that is 2. And you've seen dotted lines like this for guides before, but only for asymptotes, really. You can actually use these dotted lines to guide any part of your graph, because again, they're not considered part of your final graph as long as they are dotted. With that in there, I can now start plotting my other ones. At 3 pi over 2, I hit that middle. At 3 pi, I'm at the bottom. At 9 pi over 2, I'm at the middle. At 6 pi, I'm at the top. And I can keep this going if I want. I've got the space. Why not? So I can get all those points in there. It's not necessary. The question asked just to show one period of this, but I can do that all the same. I have that option. It would be a little more work and I would have to consider my time, but that does work. Connect the dots. And again, not doing this. Definitely not even doing this. But make it look like you gave it a good shot. And you said to yourself, yeah, I really want this to resemble the actual graph as much as possible. So we do that. Sketch, 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 sketch. Arrow, arrow, done. This would be another 2 marker. The ones on the next page are 4 mark doozies. Give them a try, give them a go, and I will, of course, proceed pretty quickly. Oh my gosh, there's a lot going on here. All right, things I'll note to myself. I've got a range, which times 2 minus 1 brings me from -3 to +1, which means I've got a mid value of -1 halfway between those. This tells me that the period is 4 pi. this tells me that the initial key point is when x is equal to pi over 3. I shifted pi over 3 to the right. And based on the period, I can say other key points happen every quarter of the period. Every 1/4 of the period. So using this information, initial key point on the parent function would be 0, 0. So transforming that, we're going to shift this thing, we're going to multiply it by 2 for the x values, which changes nothing there. We're going to shift it right pi over 3. Oh, sorry, not 0, 0, 0, 1, because this is cosine, not sine. And then the other thing we're going to do for that, so the y values are going to multiply by 2 and subtract 1, which gives us 1. We can use that information to graph this thing. Because we have an initial start point at pi over 3, and our next point is pi over from that, I'm going to put my horizontal tick marks as being every pi over 3. Let's get some space here. I might skew this axis a little high. Doesn't have to be overly dramatic, but that's what I'm doing. That's my y, that's my x. For my vertical scale, we're going from -3 to 1. So there's 1, there's 2, there's 3, there's 1. For my horizontal scale, I mentioned that I'm just going to go every pi over 3. So that's 1. How many tick marks do I need? I need to cover a whole period, which is 4 pi. Each tick mark is pi over 3. It means I need 12 tick marks. 4, 5, 6, 7, 8, 9, 10, 11, 12. So that should cover it. This is pi over 3. That's where my first point's going to go. Where is my next point going to go? It's going to go a whole pi after that, which is 3 pi over 3s. So 1, 2, 3 pi over 3s is there after my initial point. So there's 4 pi over 3. And another 3 pi over 3s after that will be my next key point. And another 3 pi over 3s after that will be my next key point. And I can keep going in that fashion. And that's all. I don't have room for the rest. Now I can start plotting things. I said this thing starts at the point pi over 3, 1. It's cosine, right? It starts at the top and then goes down and up. And then at my next key point, I should be at that middle area, which would be shifted 1 down. Let's note that for myself. Boop, 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 boop. Boop, 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 boop. So next one is at middle. The next one is at the bottom, way down here. Then the middle again, then the top. And now we play connect the dots. gently curving. And that's that one done. Sorry, I'll leave it on screen for a sec. Yeah, that's done. We'll use the same kind of process. So there's a lot of parsing of information here that we went through in order to actually figure out what we want to do. So a bit of forethought and planning. We can use that again for this last question. Give it a try, see what you can do, and then we'll go from there. Hopefully you've paused before resuming to watch me go through this. My range here, multiplied by 4, I subtract 3, is that. And that means I have a mid halfway between -7 and 1, which is -3. The period is pi. Is key points, every quarter of that. Okay. And I've got a start here. Which is pi over 4 to the left. And I know I'm working with sine. When sine operates, it starts at the middle and then goes up, down, and down. Oakley days. I think I have enough info to put all this together. Oop, oop, oop. There's that. There's that. We will need quite a few tick marks on this one, actually, just to go all the way to -7 and +1. Actually, I guess I didn't need to draw this axis so low. Doesn't really matter as long as I can fit everything on there. But whatever you need to do. That's x, that's y. I'm going to make sure I reach -7 here. There's 1, 2, 3, 4, 5, 6, 7. So there's my -7. And I need to make sure I hit 1 up at the other end. Somewhere we have a halfway point. That should be -3. So there's that. And if I want right now, I can even put that dotted line in a little early. Next up, scale for the x-axis. Looks like we're doing this every pi over 4 units. Every pi over 4 something's happening. So that can be pi over 4. That can be another pi over 4. That's 2 spaced over. That can be another pi over 4. We shifted left pi over 4, so I'll mark one on the left as well. And that should be all we need. We shifted left pi over 4. So what was 0, 0 on the original goes left pi over 4, so negative pi over 4 and something, whatever the y value is there. 0 times 4 minus 3 is -3. So I'm going to plot that on this graph. And from there we plot the rest. 1 pi over 4 over, it should be at the max. Another pi over 4 over, it should be at the mid. Another pi over 4 over, it should be at the bottom. And another pi over 4, and it's back at the mid. And that is under the assumption that I've actually indicated what's what on that axis. There we go. And then we display connect the dots with our wonderfully curving lines. Absolutely gorgeous. That's done. Whew, that was a doozy. That was a 4-mark doozy. So in the ideal, you can do that within 8 minutes, no problem. Doing this kind of pre-work up here can really help, and especially if you map at least one point. You can map a couple points if you want to really go for it, but make sure that pre-planning is done before you just jump into the graph. There is some practice work over here. You'll also have received a whole bunch of practice work with graphing in something that you got handed out recently. So give that a go. We'll devote some class time to just working on that as well. But if you have questions, comments, concerns, please do let me know, because it is a little bit of a doozy. And if you have questions, that is understandable. But do make sure you let me know, because it's a lot to take in. And yeah, that's all I got. Tell everyone I say hello. Well, goodbye.